All right, guys, I'm going to go through the Chapter 7 study guide. Again, the test is tomorrow. We're going to go through the concepts here as well as the vocabulary terms will be on this quiz. So first off, make sure you know the vocabulary terms. There are 5: completely inelastic, elastic, impulse, inelastic, collision, and momentum. And I have the definitions here. This is on my website. If you go to my Weebly, I will have this posted as well, so you can take a look at it there. This first question: a ball of clay and a bouncy ball are thrown against the wall. The clay sticks to the wall and the ball bounces back. Which has a greater change in momentum? Well, when we think about change in momentum, there's an initial velocity hit and then a velocity coming back. So because the clay sticks, it doesn't have a rebound or any momentum after it hits, so it doesn't have any change or any momentum coming back. So its change in momentum went from whatever momentum it had to 0. The bouncy ball that bounces back had momentum going in and momentum going back. So when we think about the change in momentum, the greater change in momentum is in the bouncy ball. The next question: an object is dropped from a building just after it hits the ground. It is going the same speed in the opposite direction. What do we know about the momentum just before it hit and just after? Well, because it's the same object and the mass hasn't changed, and it's going the same velocity both right before it hit and right after, the magnitude of the momentum is going to be exactly the same. In which type of system is momentum conserved? It's conserved actually in both. It's kinetic energy that's not always conserved. In an elastic collision in an isolated system, what do we know about the final total momentum? Again, momentum is conserved in collisions, so it's going to be exactly the same before as it is after when we talk about the entire system or everything involved in the collision. Next, the person is standing in a sailboat with a fan blowing into the sail. What is going to happen with the movement of the boat and why? The boat's not going to move because of Newton's third law of equal and opposite. So there is going to be a momentum. There's going to be a force on the boat. Even if you threw something into the boat, threw a ball or something into the sail, whatever momentum you had going forward when it hit the sail, you also had going back. When you release the ball, there was a momentum going the other way. So the total momentum, or the net momentum, is going to be 0. In a collision between two unequal masses, which mass receives a greater magnitude impulse? They're going to have equal impulses. Now that doesn't mean they react the same way. They have the same impulse, but if one's bigger or smaller, they may react differently. They may travel at different speeds after collision and things like that, but they have the same impulse. In billiards, the cue ball hits the 4 ball and stops. The 4 ball moves away with the same velocity as the cue ball had originally. What type of collision are we talking about? This is an elastic collision in this case. So the next one, determine the type of collision. So here, notice, I have two masses of different size. So I have 3 kilograms and 6 kilograms moving at different velocities, 3.3 meters per second and 1.5 meters per second. After they collide, they stick together and are moving 1.8 meters per second. So they're traveling together as one mass, okay? And the key to it, I know, is they're both traveling 1.8 meters per second. So this is completely inelastic. Completely inelastic, meaning they stick and travel together. If they would have bounced apart, they would have just been inelastic. All right, in a collision of two identical objects, one moving and one at rest, what do we know about the amount of kinetic energy after the collision? The amount of energy is going to be half as much. The amount of kinetic energy is half as much because you have twice the mass afterwards, so you're going to have half the kinetic energy. All right, the next one, the magnitude of momentum of a 0.24 kilogram object dropped from rest at a height of 3 meters just before it hits the ground. So to solve this one, I gave you some hints here. First, we know initial potential is going to equal final kinetic. So the energy through conservation of energy is going to be the same at the start as it is at the end. So if I solve for my initial potential energy, and that's these first two steps, I can solve for potential energy, which is also going to be my kinetic energy, okay, which shows here. Once I have kinetic energy, I can find the final velocity. So I plug my value in here for kinetic energy, 1/2 mass velocity squared. So now just solve for that final velocity. And in this case, when we solve for our final velocity, double check, make sure I got the right value here, 7.0362. All right, so I did take the square root of the answer. This should not be squared, this value. The squared should be gone. So that is our final velocity there. From here, once we know our final velocity, I can plug that value in right here for final velocity to find the momentum, which is what we wanted to find. Plug my values in, and I find my momentum is 1.84 kilograms times meter per second. So notice, I started with potential energy, changed it to kinetic energy. From kinetic energy, I found the velocity, and then plugged the velocity into my momentum equation. Next question says, in a system, there are multiple momentums. How do I find the total momentum? Momentum is summative, meaning just add them all together. A 0.20 kilogram ball traveling horizontally at 27 meters per second hits a wall and rebounds at 21 meters per second. So I want to know the magnitude of the change in momentum of the ball during the rebound. So now remember, magnitude's not negative. If you come up with a negative, that's just showing direction. And in change in momentum, a lot of times you get negative because of change in direction. So to get my change in momentum, I am going to do my final momentum minus my initial. So I'm going to solve for those values. My final momentum, negative 4.2 kilograms times meter per second. And I did negative there because of direction. My initial momentum, 5.4 kilograms times meter per second. I'm doing the 27 meters per second times 0.2 to get that value. Now I'm going to use this equation. I'm going to do, this is backwards, should be final minus initial. So negative 4.2 minus 5.4. So again, let's strike this because it's backwards. We are using this. So final minus initial in this case, and I get negative 9.6 kilograms times meter per second. But again, because magnitude isn't negative, my total change in momentum is 9.6 kilograms times meters per second. All right, to calculate impulse, impulse is just change in momentum or force times change in time. So in this case, just plug in my values, 3.7 times 2.1, and we come up with 7.77. So off on that should have 7.7 for this answer when we do 3.7 times 2.1. On the next question, when we go through here, 420 gram air track cart traveling at 1.05 meters per second. Right away, something should be, a red flag should be going up. We need to convert grams to kilograms. So in this case, a 420 gram air track cart, we need to convert that to 0.420 kilograms. So in here, in elastic collisions, kinetic energy is conserved. So I ultimately want to find my final speed. It says, what is the speed of the cart just after the collision? So conservation of energy tells me my initial kinetic and my final kinetic should be the same. So I'm going to start plugging in my values for my initial kinetic energy and my final. What I don't know is my final velocity, and that's what I'm going to solve for. And with my final velocity, when I solve for it, I get 1.12 meters per second. All right, On the last one, two dogs, Rover and Fido, run on a level frictionless surface. Rover runs eastward with a momentum of 27 kilograms times meter per second. Now, if we remember, these are vector quantities. So this one represents Rover running eastward at 27 kilograms times meter per second momentum. Fido runs northwards, so that would be this vector. They make a sudden, perfectly inelastic collision. What is the magnitude of their combined momentum after the collision? Well, what we're looking for is this resultant vector. And we solve that by doing the Pythagorean theorem. And we find that our final momentum in this example is 29.5 kilograms times meters per second. So that is the review sheet. If you have questions, feel free to email me or stop by before school tomorrow and I can answer any questions you have. This test will be Thursday.